Lesson 29 is solving literal equations. So to define literal equations, we would just say that they are equations that have more than one variable. Okay? So we will just jump right into it. Example 1. I feel like the easiest way for you guys to understand is just doing a mass amount of examples. So if you feel like we need to do more examples at the end, just let me know. We can go into the lesson practice and get some done. Okay, it says solve for y. So we have 2x plus 3y equals 10. Now where I've seen my Algebra 1 students struggle in the past is that they think that we deal with it differently than we did before. It's nothing different. We're just isolating a different variable. Before we were solving for one variable. We're still solving for one variable. We just have to decide which one that is. It said isolate y. And there's a reason for this, because later on in your mathematical careers, you're going to have to solve things and put them in y equals mx plus b form. So what we are practicing now is getting them into y equals mx plus b. So we're isolating 3y. I want to get that 3y by itself, and then I'll deal with the next thing. Okay? So right now I'm having 2x added to 3y. What do you think I need to do to get rid of 2x? I need to subtract it. I subtract the entire entity. Okay? I subtract the entire thing. And what I do to one side, I must do to the other. So this property that I just used is subtraction property of equality. Or subtraction PO. Okay? So I did that to both sides. I got rid of my 2x off of one side, and I have 3y left now. Sorry, my pencil is apparently trying to die. Okay, 3y equal to 10 minus 2x. Now I'd prefer for that variable part to be in front, but I don't want to confuse you on the first example. So all I did was simplify right here. Now, how am I going to get rid of and isolate my 3y? What am I going to get rid of? I'm going to get rid of my 3. I'm going to do that by dividing it by 3. Now, what I do to one side, I must do to both sides. Okay? When I say sides, remember it's that equal sign that is making my two sides. I'm dividing the entire side by 3. So now I have y equals. Now this is where a lot of people get lost, so ask me questions if you don't understand. This 3 is dividing everything, each term. So it's 10 divided by 3. And negative 2 divided by 3. Okay? It goes to each thing. Because I'm dividing or multiplying, it's almost like a distributive property. If I was multiplying each side, you would distribute that 3. But I'm dividing to each side, I'm kind of distributing that 3. It's the same as multiplying by 1/3, right? So I'm actually done right here. I just need to finish my steps. Division, property of equality, simplify. Pretty much after every piece that I do, I'm going to have to simplify immediately after. Now, when I said that I want this in proper form looks like this. Y equals mx plus b, right? Where m is some number and b is some number. So this would be y equals, because this is minus 2/3, it would be a negative 2/3 x. And since this is positive 10/3, it would be plus 10/3 in the back. So that's proper form. Okay, this is proper form. This is the commutative property that allows me to move all of these around. Okay, the commutative property allows me to do that. Any questions? There's got to be someone. All right. Example 2 then. Example 2 says solving for variables on both sides. So it's the same kind of concept. We're just going to add in a few more steps. So we got 4p plus 2a minus 5 equals 6a plus p. Okay, I have now two different variables, so when I combine like terms, I have to be careful that I keep the people with the same last name together. All right. In this, they want us to solve for the variable p. That means I need to get all of my p's on one side and everything else on the other. So, how am I going to get my p's on one side? Which one should I move is basically what I'm asking. I probably would do that. I'm with you there. Okay, so I'm going to move just the one p. So minus p on both sides. This one goes away. I'm left with just 6a on this side. And I'm left with 3p. And then I just drag the rest of this stuff down. Plus 2a minus 5 equals 6a. Okay, questions there? Okay, next step, I need to start moving everything else to the other side. So, because I have a 6a here, I'm going to move my 2a. How am I going to do that? Subtract it, because it's being added. I subtract 2a to both sides. Drop down my 3p. That cancels. Minus 5 equals 4a. Now, what do I need to move? What's left to move? 5. So how am I going to move it? I'm going to add it. So I add 5 to both sides. That cancels. I'm left with 3p equals 4a plus 5. Now I have this guy that's next to my p. Divide to get rid of him. So I'm left with p equals what? See if y'all really did understand that first one. 4. I want you to write it like this, and it's for a specific reason later on in your mathematical career. 4/3 a. Okay? So instead of 4a over 3, let's write it as 4/3 a. Okay. Anyways, going on to the next one. 5 over 3. Good. Okay, and I'm done right there. As long as I have p by itself, there's no one bugging him, there's no one adding to him, there's no one multiplying or dividing to him, we are in good shape. Okay, and that is your final answer. So justifying my steps as I go: subtraction, property of equality; subtraction, property of equality; addition, property of equality; division, property of equality. Okay, so if it tells you to justify your steps, split it into a 2-column style proof, and you can easily do that. Okay? Do not forget to write property of equality where property of equality applies. Any questions there? All right, this one is a little more confusing, but you're going to see it a lot. I see this thing every year, and I see it about 10 times every year. So make sure that you understand what we're doing on this one. C, which is actually stands for Celsius, equals 5/9, open parentheses, F minus 32, close parenthesis. Now it wants us to reverse this formula. Instead of going from Fahrenheit to Celsius, it wants us to make it to where I'm going from Celsius to Fahrenheit. So I need to isolate F. And this is a common conversion that we'll have to do in science, and we will see this conversion a lot in our mathematical careers as well. Okay? Backwards. Yes. So what's weird here is that I actually have lots of options. I can distribute this 5/9 and then undo everything at the end. I could do that. However, I don't like dealing with fractions right off the bat, so I'm not going to. So the easiest way, starting to look at this, I would say I'm going 5/9 multiplied by F minus 32, right? So how do I get rid of a 5/9 multiplied by? I divide by 5/9. So if I divide everything by 5/9, my 5/9 will cancel, but I also have to divide C by 5/9. What is the deal with fractions? What do I do with them instead of divide? I multiply by their reciprocal. So instead of dividing by 5/9, I'm actually multiplying by 9/5, right? So C multiplied by 9/5. Or I would write that better. I like saying the coefficient before the variable, right? So it would be 9/5 multiplied by C. Did I confuse anybody there? Feel like I would have. Okay, so remembering that we can't divide fractions, we multiply by their reciprocal. We get 9/5 C on the left, and our 5/9 canceled out, so we have F minus 32. Now, instead of having to distribute and then move everything, I just got rid of my 5/9 to the other side, which was really nice, and I now just have to get rid of that 32 that's bothering my F. How am I going to do it? I add to both sides. So this is another common mistake I see. I see a lot of people going 9/5 C plus 32, and they're going, oh, I have to add that together. Why can't I add them together? They're not like terms. They don't have the same last name. So instead of overthinking it and going, I don't know what to do, I have to ask in the morning, you just rewrite it. 9/5 C plus 32. That's it. You just rewrite it. If they are not like terms, that is in its simplest form. You just rewrite it. Okay, and then I'm left with just F on my right. Questions? Okay, most common mistake, again, is I see somebody distribute this out and then they have a lot more work to do than they anticipated. You'll still get the same answer, it just won't be in the same form as this. All right. Now it wants us to go ahead and do a substitution. Okay, so the original problem said the formula expresses Celsius temperatures in terms of Fahrenheit. So find Fahrenheit temperature when the Celsius temperature is 20. So we're going to plug it in for 20. So it said C is 20. So I've now converted it. I'm going to put C in for, or 20 in for C. So I have 9/5 multiplied by 20 plus 32 will give me my degrees in Fahrenheit. So now I have 9/5 multiplied by 20. This should simplify down to 4. Okay, so I have 36, I think, plus 32 equals F. 36 and 32 make 68 F. So what is my label on 68? Degrees Fahrenheit, right? And that would be my final answer right there. Questions? Okay. Example 4 then. It says the formula for the circumference of a circle is circumference equals 2 pi r. If the circle's circumference is 24 inches, what is the radius? And leave the symbol pi in that answer. So it's just saying don't multiply out pi. Leave it in terms of pi, if you will. Okay? So before we do this, I'm going to convert this to where I can get my answer for radius. Okay? I want to isolate r. So what is currently happening to r that I need to isolate? What do I need to do to get rid of the stuff bothering it? What is the operation being performed to r? Multiplication. So I have to divide it. What am I going to divide it by? Oh. I want to get r by itself. Why would I divide by r? Because if I divide by r, now I'm going to have a c divided by r. I'd divide by 2 pi, right? So I'm dividing by 2 pi. A lot of you might want to try to divide by 2 and then divide by pi. You can do that. You won't get the answer wrong. However, it is a lot easier to move everything all at once than it is to do it separately. So 2 pi, that's just a number. So divide that on both sides, we get 2 pi. So 2 pi is now canceled out. R then will equal circumference divided by 2 pi. And now I can solve. I plug in, it told us our circumference was 24 inches. So I'm going to plug it in. 24 divided by 2 pi. And it said leave it in terms of pi. So I have to leave it in terms of pi, but what can I do before I do that? How can I simplify this more? Think of it as 24 over 2. 12 over 1, right? I can reduce it by 2. So I can reduce each of these by 2. So I'm left with 12 over just pi, because 1 times pi is just pi. So my radius would be whatever 12 divided by pi is. And then I need a label for it, right? What is my label? In inches, right? Answer. And again, a lot of people get confused with pi. Pi is just a number. It's 3.14 and some other random onslaught of numbers that go on forever. So they'd say leave it in pi so that you're not approximating. Questions there? Okay. Example 5, application of traveling plans. So I do a lot with traveling plans. I have to find out how much gas I'm going to use, how much it's going to cost me, and then I go from there. And then every once in a while, when we're doing a military movement, I want to know how much it's costing the military to drive from Clovis to Roswell. I'll give you a hint. It's around $1,000. It's ridiculous for 30 guys to go to Roswell. So I find these kinds of problems interesting. We have to recall what the formula for distance is. It's distance equals rate times time, which is dirt. Okay. A lot of y'all probably learned dirt. The Ramirez family is taking a trip to the coast. They live 270 miles from that coast. They want to make the trip in 4.5 hours. Use the distance formula, and then they give it to you, to determine the average speed the family needs to drive. So we're using the distance formula to find rate. So before I do that, I want you to isolate rate. What is currently with our rate? Time, right? So how am I going to get rid of it? divided by time. So that cancels out our time. Now r must equal distance divided by time. So I'm going to go ahead and take my distance, 270. I'm going to divide it by my time. And we already kind of knew how to do this, right? Everybody kind of knew how to do this in their head. Now we have an algebraic way to see how and why it's done. So 270 divided by 4.5 is what? 60. 60 what? Miles per hour. And we want to keep that in mind, right? This is 270 miles, and this is 4.5 hours, so it's miles per hour. Okay, or MPH, I'll take that too. Questions, comments, concerns?